Hello, everyone. I don't know whether this is live or not. You're going to need to tell me because I know that it says we're live and then like you end up chatting away to yourself. Oh, going to need to tell me I can hear myself. Wait. I know that it says. Wait. Let me sort this out. Otherwise, we are going to get disastrous feedback going on here. Which will not be good. Okay, I can't see myself as before. So what I'm going to do is just assume you're there and keep an eye on the, I'm going to keep refreshing this page until I can see you. And then hopefully we will be able to touch base. So why am I here? Basically, I'm here because you asked me to do some revision with you for maths A level, and basically I'm all yours. I think my lesson today that I'm doing in an hour is going to be with the TOTUTORS students. That's going to be focused on statistics. We did mechanics last week, and so we're going to focus on statistics today. Oh, I can see the chat. Hooray. Excellent. Everything is going really well, technologically wise. Pierre, I am not, to be completely honest, I've taught the further maths, I can do the further maths, but there are two problems with the further maths. One of them is that not many people do it. And so if I'm thinking like, what am I going to put my time into? Should I put some time into helping students with physics, particularly the maths half of the physics, because I've done the physics, then, or versus help it, like which group of students needs more help and is there more of, just in terms of like helping students. Like if I came on here and said I'm doing further maths, we're narrowing it right down to a really small number. If also, and this is the other problem, which just makes it a complete no-no, is that the further maths course is like loads of different combinations of units that you could do. So well, Megan, we can do whatever you like. We can do stats or we can literally do whatever you like. So with the further maths, I would have to do like 6 times as much as you're doing in order to cover all the potential options that people are doing. Plus that means when I come on, if you want help with a certain thing, it might not be in a unit size. So at the moment, it is not my priority. I am really sorry. It's the A level that's my priority. Right. Okay, Salah, perfect question. What would I recommend doing from now to the exams and how would you balance the stats and mechanics? Okay. This is what I really strongly recommend that you do between now and the exam, okay? You are going to take a paper, it doesn't matter, so you've got for the A level, you've got 3 papers, right? You take a paper, either paper 1, paper 2, paper 3, or in fact, Bijan, you can even do this today. What time is it? 5. So this process would take a maximum of, well, okay, let me talk you through it and tell you how it works. You get a paper you haven't done before and you do it in test conditions. Now, this is really important. A lot of students at the moment are saying, I did a mock. It was the hardest paper I've ever done. I did so much preparation. It didn't prepare me. That is because that's probably the first paper that you've done with no music, with no being able to go up and get toast, with no social media, having to sit there for 2 hours and find your own mistakes, not marking it yourself. All these things you're doing for the very first time when the teacher forces you into that exam environment. So what you need to do is to build that into your revision, because maths is a skill-based subject. So when we go into that environment and we're adrenaline up and we're in a situation that we haven't normally done maths in, so for example, no music, it makes a massive difference, no music. Doing maths in silence compared to doing maths with music on is huge. That's why we put the music on, because we find it easier to concentrate. So then we go in an exam situation and all our structures are taken away from us, and then we wonder why we're not performing as well. So you need to build that in, okay? You do a mock in these test conditions, proper test conditions, and that involves, so no music, no notes, you've got the formula book with you, I'm not sure if it's in the formula book, you have the formula book either on a screen or printed out. You have to give yourself the full 2 hours, and if you finish early, you have to make yourself sit there for that 2-hour period using checks. So subbing numbers back in, doing this thing where, say you've done like partial fractions, or something where you've rewritten this like this, then you sub any number you like into this, jot down what it is, sub the same number into this, and they should come out the same. So you can check your accuracy. It doesn't, checking accuracy in maths shouldn't be like, oh, I wonder if I went wrong. No, you did go wrong. So what you're trying to do, and not because I'm criticizing you, but because we all go wrong, including me, all the time. So what you're trying to do is locate that mistake, locate the problem, and practice doing that before the exam. So what a lot of students do is the first time that they ever truly tried to find mistakes, truly, is in the exam. So they haven't practiced that skill, so they're no good at it, and they don't find any mistakes. So 1, do the exam in test conditions. Make yourself do full test conditions. 2, mark it using the mark scheme or using my videos on the free trial. If you've got the free trial with the tailored tutors, that makes it a bit easier to mark, because I'm explaining what all the marks are for. And yeah, how? Yes, how? Lots of people do, especially in maths. Let me talk you through what I think you should do, and then I'll tell you what I think you've probably been doing and why I think you should switch. So you do it, you mark it, but when you're marking it, you don't write on your script, okay? You don't write, you don't annotate or circle mistakes. You have 2 separate pieces of paper, one of them for your mistakes, one of them for things you didn't know, and you keep a track on those 2 pieces of paper. You'll find this much harder. It's much easier to write down the correct solution next to your solution and then go like, oh, yeah, I get it now. I'm not doing that. Then you go to these 2 pieces of paper, you have a look at all the silly mistakes you did, forgetting units, minus signs, brackets, blah, blah. And you think, right, next time I'm going to focus on not making those mistakes. I'm going to try not to add a tally to these. And then you look at the list of things you couldn't do. Now go back to the paper, right? Look at the question, look at the mark scheme, ask me questions. I'm here every week. We do Monday and I'm doing Thursday as well. Or if you're in the course, you can put questions in the course, obviously, at any time. Just go over it and ask your teacher, ask your friends. Don't worry about any other questions. There's 50 billion, thousand million other questions. You're never going to do them all. Don't stress about that. Just focus on this one question and work on it and work on it and work on it until you think, I so get this now. I mean, I'm not sure I could do another question like this or another question on this topic, but this question, I totally get it. You work through the questions. Now, depending on how much time you've got, you might want to do some topic work, like one more question on that topic for the ones that you found hard. But don't do more than one. Then redo that paper in test conditions, the exact same paper. Then repeat, because you won't have got it all right. You'll think you're going to get it all right, and then you don't. I would say, Mohammed, do the exact same thing, but use AS papers. So you'd redo the paper, then you have a look at your things I did wrong sheet, and you have a look at your questions I didn't understand sheet, and you have to tally what you did wrong again, or you have to add new ones if you did them wrong. And then you have a look at the ones that you couldn't do last time, and you think, oh, I really thought I'd fixed that. But then when it came to it, test conditions, I blanked again. I wasn't sure. So you repeat that process. You look at your list of mistakes. You think, right, mental note, will you please stop forgetting plus C? And then you look at that list, you go back to those questions, you work on it, If you want, do one more topic question, no more than one. Then you repeat the same paper. Now you might be thinking, this is stupid, right? Because I could have done, in that time, I could have done 5 past papers. Yes, you could, and you'll make virtually no progress whatsoever because it doesn't help. Doing a paper, annotating the paper with the correct solution, and then doing another paper, you will just more or less stick at the same grade. And that might be what you're starting to feel at the moment. So it's a simple strategy. Is there anyone here today who has been trying it, who either you're a tailored tutor student, or you were here last week, or you were here on Monday for the Monday check-in, and you've actually tried using this process and it's actually making a difference, or maybe you're not feeling a difference yet? Has anybody done anything other than what we all do in maths, which is do a past paper and annotate it? Salah, I was talking to Rich about this, about biology and chemistry, and I said, is it the same? Oh, excellent. I'm really glad. Excellent. Yeah, I was talking to Rich and saying, is it the same? Because the thing is, in maths, they really are the same subjects, the same topics, just phrased differently. If you can truly do question 9 in this paper that you chose, then you've got a really good chance of being able to take most of the marks from the similar question in your real exam, because they do match up. Now, there's a video, actually, it's on our YouTube channel. If you don't believe me, have a look at our YouTube channel. I'll see if I can find a link to it. I was comparing 2 papers. So I think I just took them completely randomly, like C4 2014 and C4 2017. They're old spec, but that doesn't make any difference. It's the same people writing them. I know the people who write them. It's the same people who write them. They're writing the same style of question. And I compare the 2014 and the 17, and I say, right, let's just imagine that you did the 2014 over and over and over, and you didn't look at any other paper. That's all you did. How many marks would you get on 2017? And it's most of them, enough for a B, okay? It really, really does work. It's not something that I'm suggesting as a like, oh, you could try this. I've done it with hundreds of students. I know it works. I wouldn't tell you to do it and tell you to do something that I think might risk you not making as much progress as you could, honestly, truly. Okay, let me catch up on some comments. So the balance for pure stats and mechanics, I would say do what I just said with paper 1, then paper 2, then paper 3, keep them all kind of going like that. But if all you do is one paper 3 times, paper 1, paper 2, paper 3, and you can truly do it, you will get higher than someone who does 5 past papers but doesn't do this process. Hal, I'm awful at stats and mechanics, so are most people. It's going to be the thing you find the hardest. I think the stats is the hardest because of all the words and also because of the way the questions are phrased. I think the stats grade boundaries are going to be a lot lower than the mechanics and the pure, but I'm very happy to help you with all of it, so we can do some stats today. Bijan would like to do some forces in equilibrium. Let me jot down what it is you'd like to do, and then we can make a decision. Forces in, Bijan, are you first year or second year? So I need to know whether you've done friction and whether you've done resolving forces. OCR, MEI, you have to learn the large data set. Okay, yes, Megan, I do have advice about the large data set, which is sod the large data set. Forget the large, I mean, okay, you're not going to like that advice, right? Here's the facts, okay? Just going to have some of my ginger tea and then I'll tell you the facts about the large data set. The exam board is only allowed to ask a maximum of 3 marks in total that require you to know anything about the large data set. Okay, that is 1%. Now, the exam board can ask you this many marks about integration and trig and differentiation. Now, in the old spec, I've just started doing predictions. We're going to do that at the weekend. But in the old spec, it was about 40% of the marks were for integration, differentiation, and trig, about 40%. Sometimes it even tipped up to 50, right? So if you think about, you need to, at this stage, be really kind of strategic with your revision. So you're going to put in this much time. You want it to be for something that's going to make that much difference to your grade. Now, the large data set, if they are going to, well, they are going to ask you a question, right? That question, of those 3 marks, that they don't even have to ask 3, they could ask 1. Maximum they can ask is 3. Of those 3 marks, I would say probably 2 of them, or at least 1, are going to be things that you can just kind of blag. So for example, I'll tell you all the things I've seen on all the mark schemes so far, or all of the papers so far. They ask you to identify the outlier, okay? So all you need to know from that large data set is, these are the things it's got in it, and these are the obvious outliers in any one of those groups. There won't necessarily be obvious outliers in all of them, but if there is an obvious outlier, you could match them up. That's one thing they ask. The second thing they ask is for you to, they phrase it like, here's some data from the large data set, and it's got like 2, 3, 3, and then it says it adds up to 10 or something. 2, 3, 3, 3, 4, 5, 6, 7. They say it adds up to 8, and they say, so-and-so says that it doesn't add up to 8 because it's 2 and 3 and 3. Give a reason using your knowledge of the large data set as to why that is not true, okay? And the answer to that, and it's in for all boards, the answer to that, you don't need to know anything at all about the large data set. What you say is that in the large data set, the data is given to way more accuracy. There are lots and lots of decimal places of accuracy in the large data set, and this data has been rounded to the nearest integer or to the nearest 1 decimal place. And therefore, the actual answer is what you'd get if you added it all up with all the accuracy. But, okay, those are the 2 things. What I would suggest you do is that you make a list, and you don't spend more than 45 minutes on this at all in your whole life. You spend 45 minutes maximum, and you make a list of what the large data set has in it. So like literally what data is in it, and then add on any obvious outliers and then just walk away, leave it. The amount of time you would have to put in to that large data set is huge. The only other bit of advice that I would say about the large data set is this: when you're doing a past paper question, so you're doing it in test conditions, okay, you're going to come across a question, it's a large data set question, you don't know what the answer is because you haven't wasted your life looking at it. When you mark it, don't look, right? You know you didn't know that. Don't look at the answer. When you get to the mark scheme, cover that up, do not let yourself look, and then go to the actual large data set and try and answer the question using the large data set. Because what that's going to do is just a little bit as you go along, every time you do a paper, you'll come across the odd question. You'll get a little bit more familiar with that large data set, but you're not wasting revision time. An hour is an hour you could be spending doing half a past paper or making progress with a particular topic. That is my honest advice on the large data set. And I'm just going to catch up with comments. Okay, so I'm kind of scrolling through to see if I've missed anything. When do you recommend doing the second paper? When you get 95 on the first paper. Okay, so when you get 95%, then you know that, and then try a new one. Anna, yeah, I haven't even approved everyone for the class that's going to start at 6 o'clock. So when I finish this, I'll approve everyone. So don't worry about that registration. Okay. OCR MEI 2018, I have seen. I didn't think it was that difficult, to be honest. I thought the OCR 2018 stats was, of everything that I've seen, I thought that was the most difficult. Okay. Questions. Do you want to do forces in equilibrium or do you want to do something else? And if you want to do something else, then what would you like to do? We can do any topic you like. I've got lots and lots of past papers lined up that we can have a look at. Completely up to you. Ria, you would think that you would just memorize the method, but the thing is the methods are all the same. So all you're going to be doing, you kind of do want to memorize the method from the mark scheme, because then you look at the question and you're like, okay, this is the same one that I did, but that is a 2 and that's a 3 and that was a 5. So I can, you will see when you do that second paper. Well, ask people who's done it. Has anyone done a second paper yet and got any higher than they got on the first paper? Does it work? Aisha, I think the 2019s will be very similar to the 2018s, but the grade boundaries will be lower, because you're completely right. The 2018s was just a further maths cohort. So there was a bit of adjustment going on there. So we've got, I mean, I think for EdXL, we've got about 60,000 people taking the EdXL A levels this year. So that is a lot of people, and the grade boundaries are going to be obviously normalized using that data set, which is a lot more than last year. Moments, we definitely can do moments. Okay, Abin, I would definitely do the OCR and the MEI for revision. What I've done, if you have a look in the revision kit, what I've done is to chop them up for you. So if you go into the EdXL one, I've made practice papers using the OCR and the AQA. So there's a list of 4 practice papers in there for you that are organized so that you can do them an hour at a time, or you can kind of create a past paper by doing pure. Then if you're EdXL, it would be pure, and then stats mechanics. Whereas if you're AQA, it would be pure mechanics, pure stats. So you can kind of build them. If you have a look on the free trial, are you all in the free trial? You definitely need to join the free trial, okay? Because there's loads in there, and even if like you can't afford or you don't want to pay the 30 quid for the next month, £1 a day to be able to ask me questions 24/7 and have access to the whole thing. But even if you can't do that, I want to make sure that I'm on here helping you out, and you can have a look at that free trial and at least go through all of that stuff. Okay, yeah, I will be, the AA star boundary will be, the AA star boundary is difficult. I would say, what would I guess? Well, it used to be quite high, didn't it? It used to be like 88, 89%. A complete guess, I would say the AA star boundary will be on about 85%. And the A boundary will be on more like 79 or 78%. That is my guess, but it's a complete guess, okay? Okay, I'm gonna answer Abin's question about integration. Yes, the Mad Dog, I think definitely you've got to keep all three going along in a little spiral. Yeah, totally. You could even do one day, then the next day, then the next day. So P1, P2, P3, paper one, paper two, paper three, paper one, paper two, paper three, and then whatever you do that day, that's your paper one day. So yeah, you could do sort of 2 days a week on paper one, 2 days a week on paper two, 2 days a week on paper three, but you need to keep them all going. When you're doing the past papers, if you go in the revision kit, that's why I broke them in half. So the actual papers are 2 hours. You should do it in 2 hours. You should practice doing it in 2 hours. My partner is a teacher, and yesterday he was invigilating a mock exam that was 2.5 hours long, 2.5 hours in the hall, in exam setup, proper mock, not in the classroom. And after about 1 hour, most of the students in the room had their head on the table or were leaning back in their chair because they couldn't concentrate for more than 1 hour, because they'd never tried to concentrate for more than 1 hour. And this was a 2.5 hour exam. So it really is important that over the next few weeks, you force yourself into this 2 hour silent, hideous condition where you need to focus for that whole time. Okay. Aisha, which exam board is that? Not Edexcel. I only know Edexcel because I only mark for Edexcel. Edexcel, on average, for the old specification, was an average for an A grade of 83%. 83% is the average percent for an A grade for Edexcel over the last few years. Do you mean the new spec? You're talking about the 2018 new spec. Okay, yeah, but that is, the thing is, that cohort are a funny cohort. That's all I'm going to say. It's, you cannot look at that. I'm talking about, what I'm thinking about is my knowledge of the cohort that do the A-level papers, which is a huge number of students, about 60,000 students. And I'm saying that, and also teachers, what teachers have done this year. I know a lot of teachers, I know what teachers have been doing, and I know what the papers are designed like. And don't forget, I write the mark schemes, so I know how the mark schemes are designed. And I don't think the boundary for an A star, honestly, I might be totally wrong. Don't bring this up in August and say you were wrong, you didn't get it. Obviously, we set the grade boundaries after the paper is completed. So I have no clue. My instinct is that an A star A boundary would not be as low as 78%. I would be really surprised. I would say 85, lowest. Oh, I don't want to go as low as 82 even. Anyway, this is silly, right? We don't need to, it doesn't matter, does it? Aisha, if the grade boundary is 82 or 78, you're not going to go, oh, that's all right then, I'm not going to do as much work. You're still going to work really, really hard. It makes no difference what the grade boundary is. You're still going to work, aren't you? So, Tavs, I would recommend, look, if you've got 1 day before a mock, if you've got tonight, then what I recommend you do is 1 paper. That is it. You do the paper. In fact, if it's tomorrow, you haven't even got time to do it in test conditions. Get a paper and get yourself to the stage where you can do every single question on that paper. Not just do it, not like I've learned the mark scheme, but if someone asks you to explain it to them, you could explain it to them. That's what I recommend you do. And then I guarantee you enough of those questions will come up. Okay. Okay. So we've got forces, but also hypothesis testing. I think I'll go with hypothesis testing because it's pretty straightforward, to be honest, and there is a set way to get all of the marks. So I think what I'm going to do is share my screen. Actually, no, I won't share. I'll share my screen. I'll share my screen, and then I'll write a bit, but then I'll come back to talking about you. So hypothesis testing, okay? So first years, you've got hypothesis testing for binomial. Second years, you've got hypothesis testing for binomial, and you've also got hypothesis testing for normal and for correlation. So what does it look like if we've got binomial or normal or correlation? You're always going to start with the same null hypothesis, okay? In all cases. For binomial, it's about P. For normal, it's about mu. For correlation, it's that rho is 0. Always exactly the same. Your alternative hypothesis, someone asked me a really good question in the course the other day, which was, how would you know that it was a two-tailed, how would you know it was a one-tailed test when the question says, find evidence for whether or not the claim is correct, whether or not. So that makes you think two-tailed test. No, 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 no. You are always testing whether or not a claim, whether or not there is evidence about a particular claim, okay? That is what you are testing. Is there evidence to suggest that? This is what the questions will say. To suggest that, or so-and-so claims, that is the bit that you need to look at. You need to look at what they are claiming. So someone claims that. Someone claims this, okay? Or someone said that. That's what you look at. And then that thing gives you your alternative hypothesis, which is also about this particular variable. Now, there is a mark in the mark schemes. It's the most clear in OCR, but it's also really, it's the most specific in the OCR mark schemes, but it's also there in the EdXL and in the AQA, that you need to get a mark, or you can't get the mark for your hypotheses unless you've defined your variable and your parameter. So make sure, this is like an extra step that you might not think you need to do, but actually you do need to do. You must say X is binomial, blah, blah. You must say X is normal, blah, blah. You must not say anything about correlation, because correlation is correlation. Then the mean, then you can say what your alternative hypothesis is. So that green bit, that's an extra mark. Or rather, it will mean that you lose the mark for the correct hypotheses. So if the person is claiming that there's more, you put bigger. If the person is claiming there's less, you put less. If the person is claiming it's just simply not that, then you put not. So this is for less. Maybe I can, yeah, I'll just do this bit in red. That bit is if they think P is bigger, is the claim. This is if mu is smaller, is the claim. This is that there is correlation. Not saying there's positive or negative correlation, just there is correlation. So that is a one-tailed test, a one-tailed test, a two-tailed test. Now, if you have a one-tailed test, then the significance is alpha. The significance level for the test is alpha, and that's what they give you. Same thing here. If it's one-tailed, then the significance is alpha, the end. If it's two-tailed, then the significance is half of alpha. Okay? To see if there is any change, two-tail, increase or decrease, one-tail. Yep. Optimistic is one-tail, H1 is, yeah, but it's not that, yes, H1 is that P is bigger, or H1 is that mu is bigger, or H1 is that rho is bigger. So it's not H1 that's bigger, it has to be, you have to be talking about P in the case of binomial, about mu in the case of normal, and about rho in the case of correlation. Okay, now, what we need to do now is one extra job for the normal. You need X bar distribution. So this is your extra job. X bar is distributed normally. The mu is the same mu, but the standard deviation is the standard deviation over the square root of the sample size. Okay, that's your extra job. These are little extra bits that you really must put in there. Otherwise, you are going to start dropping marks. You don't need to do any extra job for the binomial. You don't need to do any extra job for the correlation one. Okay. Yeah, approximating we can do, but later. This is literally just the hypothesis testing. Okay, now we are going to draw a little diagram for each situation. The binomial situation will look like that. The normal situation, well, that's not very good, but there we go. The normal situation will look like that. And the correlation will look like this. -1, 1, 0. Okay, that is the mean. And this is just like, this is what we would expect. So this is NP. Do you know that with a binomial, N times P is the mean? That's what you would expect to happen, N times P. So that's the high bit, okay? Yes, Ibrahim, you're completely right, but look what I wrote. It is the variance, which is the standard deviation squared, divided by N, which is root N squared. You're completely right. Variance over N is variance, but we're not putting variance in the calculator. If we standardize, we don't use variance. So usually people here write the standard deviation squared so that they use the standard deviation in all of the calculations. So the standard deviation is the standard deviation of the square root of N, okay? If you're given the variance, you will be given the variance, it'll be here. You will be. That's the variance of the population. That's the mean of the population, or what we think is the mean of the population. This is the mean of the samples. This thing here is the mean of samples of size n. It has the same mean, but it has a different standard deviation. You will be given it. It will be there, and then it goes in here before you do this job. Okay, picture, 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 right? Then we're going to have a look at how weird our result is. So get your result and have a look. Now, this one, this is saying bigger, which means that down here would be evidence. That would be good evidence, wouldn't it? If I'm claiming that it's bigger, then I want big things. So this is going to be weird, all this stuff here. Weird, weirdly big. Okay, because we're expecting that. In the normal distribution, we're expecting this, right? Skew is not in, it doesn't matter. I just drew a random picture. Skew isn't in the new A level. I always draw this. If you see my lessons, they always look like that. You could draw it symmetric if you want, it doesn't matter. It's just to give my brain an idea of what I'm looking for. So in this one, it's bigger, so I want weirdly big. In this one, it's smaller. So what I'm hoping for is weirdly small. I want to be down here. I'm expecting mu. This one, rho is 0. Well, rho is 0. If I'm saying it's not 0, then I don't mind whether I'm weirdly small or weirdly big. It doesn't make any difference to me. I just want weird. So this would be weirdly small, and this would be weirdly big. And I don't mind, because I'm not making a claim about it being particularly big or particularly small. Now you get your calculator, okay? You get your calculator. It tells you what this value is. Let's call it X. It tells you what happened. This is what's called your test statistic. This is what actually happened, X. So X is the mean of the sample of size n, or X is the number of times I got success on the binomial, or X is the actual PMCC of data. Right? Now, this is the area to the right of X, the probability that X is bigger than or equal to that number. That's what you find out from your calculator. This is the probability that X is less than or equal to X. I wouldn't memorize these, by the way. No way would I memorize them. I'd make it try to make sense to you, because if it makes sense to you with these little pictures, then you don't need to memorize anything. I always draw these pictures. Now with the correlation one, we're not actually finding the probability of, we're not actually finding a probability at all. What you're going to do is you're going to go to the tables and you're going to find what is that cutoff point there and what is that cutoff point there. It only tells you the positive one. And then you see whether or not your X is in there or not. Okay. So binomial. We found that probability. Is it small? Small, this is called the p-value, by the way. Small p-value, that means weirdly big, so significant. Okay, small p-value, That means tiny, tiny little area, which means we're squashed down one end of the normal distribution, which means significant. SS, small, significant. Significant. Okay. For your correlation, what you do is you just see whether or not X is in there or in there, because if so, it's weirdly big or weirdly small, in which case, cool. Okay. Right, now, final thing, and then we can try one if you like. Final thing is your sentence. You have to do 3 things. Some mark schemes, you get 3 marks for this. Some mark schemes, you just get 2 marks, but 3 things, always 3. First, you compare P, which is your p-value, and alpha, which is your significance, always. Compare P and alpha. You say which one's bigger. Alpha is your significance level, P is the area that you've just found. We're hoping it's really, really small, because that would mean we've got a really, really weird result. For the correlation one, you state what R equals as the critical value. So that's the one you get from the tables. That's this one and this one. Then you say whether or not R is bigger than that or smaller than that. So you compare the R with the PMCC that you got from the data, which is this guy here. Comparing that X and this R and saying it's smaller or it's bigger, or saying this X and this R, which one's smaller or which one's bigger. Second sentence is reject H0 or don't reject H0. Now we're going to reject H0 if we've got, I think it's easiest to not think about when do I reject H0, when do I accept H1, when do I reject H1, it's just confusing. The easiest thing is if we are weirdly big, we reject H0, because this weirdly big thing has happened, which wouldn't happen if H0 was correct. So weirdly big, reject H0. Weirdly small, reject H0. Inside here or inside here, reject H0. Otherwise, don't. Only if you've got a tiny, tiny little p-value do you do the rejection. Then final sentence is context. And this is where you're basically going to copy the question. There are words in the question, almost like secret words, which are in the mark scheme that are bold. And if you don't use those words, you don't get the mark. So it might say, so one that I did the other day, it said there is or is not, can't remember, significant evidence that the trees in the wood are smaller than whatever. The trees in the wood. If you just say the trees, you're not going to get the mark, because the claim was about the trees in the wood, not the trees. Okay? So just when you're doing that context sentence, just copy the question. There is sufficient evidence to suggest that blah, 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 blah. Just copy the claim that was made, all of the words in the claim. Okay, I'm going to go in a minute because we've done more than half an hour and I was meant to only do half an hour, and I need to just set up my web class and make sure everybody's accepted and everybody's got the link. So I'm going to come out of here. I hope that was helpful. There is okay, it's 2 things you can do now. One of them is go have a look at the free trial and enroll in it and have a look, because there's lots and lots of stuff in there that you can have a play around with and you can have a go at, and you can like try out the things and hopefully get a load of benefit like this. That's 1, free trial. 2, if you are a tailored tutor student, then just put questions in there and I can help you out. 3 is, and this is more useful, I think, if you're on YouTube and you're not a tailored tutor student, but you want to get the most out of what I'm doing on YouTube. If so, have a look at the video that was posted 2 days ago, I think, and it's called Maths in 15 Minutes Parametrics. So what I did was I just hopped on when I had a free 15 minutes and I zoomed through a topic, which was parametrics. Now, in the comments, I've said to people, if this is helpful, then tell me what you want me to do next. Now, at the moment, there's only a couple of suggestions in there and I want it to be really, really helpful. So if you are on YouTube and you want to get the most out of just the YouTube stuff, subscribe to the channel so that you get a notification when I'm coming on. And then also, could you go to that parametrics one? It is, if you click on videos, then it's like the 4th one or something like that. It was only a couple of days ago and it's called Maths in 15 Minutes Parametrics. And just, you can watch it obviously, but also in the comments, you tell me what you're struggling with the most. All right, and then what I can plan to do is look at those comments. When there's a few comments up there and I feel like I've got a good bulk of people that have told me what they want to do rather than just one or two, then I will do a 15 minutes on that or resources on that or whatever you want, okay? What was your question, Abin? The answers, right, Ibrahim, there are full, let me show you. This is important. I can't put all the answers on YouTube. Well, I could, I suppose, but it would take flipping ages. What I've done, let me show you. So in the free trial, there is, let's make me smaller so I don't have to see that. Right, this is the free trial. In the free trial, there is a course called Revise by Topic. Okay, Ibrahim, this is for you and for anyone else who watched that parametrics. You go down to functions and graphs and you click on that little thing there in functions and graphs. And then at the bottom, you see parametric functions. You click on parametric functions. You do not need a tailored tutors course to do this. It's in the free trial. You can all access it. Okay. When you click on that, what you're going to get is the questions that I gave you, the PDF that I gave you in that 15-minute parametrics thing there. And then you have got, and you can download it. And then as well as a topic summary, you've got the full solutions to every single question. Okay. So you can watch the full solutions and you can, I think there is sound, but I don't know why it's not playing the sound. But anyway, there is sound. So all the solutions are there, full work solutions to the whole thing. All right, they are there. And if, as I say, if you comment below that on what you would like me to do next, then I'll have a look at those comments and see what people want to do. Okay. Abin, the web class, Megan, is in 20 minutes. Okay, I'll go and approve everybody now and get everything set up. Abin, what was your question for integration? Okay, integration is, in my opinion, generally taught badly. It's taught in the way that books teach it, which in my opinion is badly. Integration is not actually that difficult if you start it nice and early and you just like practice it and practice it and practice it. Basically, all of integration is just one technique, which is looking at it and realizing what got differentiated. That is the only technique. Everything else is just fiddling with it to get it into the form where you can see what got differentiated. It's not as complicated as it seems. Projectile motion, yes, you absolutely, no, you wouldn't use integration, no, for projectiles. No, you do SUVAT, 100%. Horizontally, S equals UT, vertically, SUVAT, all of the things. Good, Ibrahim. That's good. So you've got plenty of time. Right, I need to go sort my lesson. You go play in the free trial and go comment on that parametrics one. I'm going to look at the comments on the parametrics video to see what it is you want me to do. I'm going to try and squash whatever it is into 15 minutes and give you a PDF and then give you access to full solutions on the free trial. Yeah, u cos theta and u sine theta is resolving the initial velocity. That's not using integration. That's resolving. So your initial velocity is u at an angle of alpha or theta, then that is split up into horizontally u cos theta and vertically u sine theta. And then for the horizontal motion, that doesn't change. It's u cos theta all the way through the motion. And for the vertical motion, that velocity decreases by 9.8 meters per second, which is why you need the SUVAT, the constant acceleration. Okay. Yeah, I know, Jack. Yes, Brown, he works at a college that I went and did some training for years ago, and he is really good. The only thing I would say is that I would recommend using the Jack Brown videos through the year, but not in the final month, because there's too many of them, and they do a lot of things that is to help you understand, but it wouldn't come up in the exam. They're like beyond what would be asked in the exam, and they're all about really helping you to understand what's going on and to unpick the topic, yeah, which is what my ultimate guide is doing, but in a more condensed form. I think for you to watch all of those videos, uses integration to solve projectiles. No, I've never seen in the whole of all of EdXL Mechanics 2 and all of the past papers I've done for every single board for the new spec. Of course you can use integration. Of course you can. Yeah, because, okay. I need to go. But you can, of course, you can use integration. Like if you've got a VT graph and I say, what is the distance traveled? If this is the VT graph, right, doing that, like a trapezium, and I say, what's the distance traveled? Then you could find the area of a trapezium. You could do suvat on this section, suvat on this section, and suvat on this section, and get S and S and S and add them up. Or you could integrate the equation of this line from here to here, integrate the equation of this line from here to here, and integrate the equation of this line from here to here. Integration gets you the area under a graph. If you integrate velocity, you get distance, etc. Of course, you can use integration, but it's not what's expected. It's not what's in the mark scheme. And I don't think it's the easiest. This is my whole point. What Jack is doing in his videos, which are really, really good, is properly explaining the maths inside all the topics. You've got what, 4 weeks till the exams. What you need is to go up a grade or two by learning what the exam is going to say and then learning how to do it, which you get by using the past papers in the way that I said at the beginning. That is what you should be doing. Yeah, and it's easier to make mistakes using integration, okay? How do you see the web class? Alice, you go to your web classes course, you click on 29 or 30, whatever it is for today, and you click on register, and then that sends me a list, which I'll go click on now, and then I approve everybody that's a Tailored Tutor student, and then you get an email link to the class, okay? Right. Go to the parametrics one, tell me what it is you want me to do. I am subscribed so that you get a notification. I'll do it at the first available opportunity, be this weekend probably. And Tailored Tutor students, I will see you in 15 minutes in class. And everybody else, I hope that was helpful. You can go back and watch this obviously afterwards and make some notes on that hypothesis testing and give it a go. See you all on either in 15 minutes or on Monday. Monday is our TT check-in thing.